Alright, in chapter 2, we're going to deal with functions, and the first section is dealing with what is a function. Now, by definition, a function is a rule that assigns each element x in set A exactly one element called f of x in set B. Now, that's the technical definition. A lot of times we refer to it as a machine, which means you put something in and you get something out in return, an input and an output. So that's kind of what these are going to look like. It's very similar to what we've had before. A lot of times we write it with f of x in mind, which means the function f, x is the variable, and then after that it gives you an equation. Now, what it's going to ask you to do at times is it might ask you to rewrite this in terms of words, like what happened. In this case, if I were to put a number in, the first thing that should happen would be to square it and then add 4. So for me, that's the word form of this function is I would square the number and then add 4. After that, they will ask you to evaluate it. And so what they mean by that is when they put a number like this, especially like the 3 that goes in here, that means that they want you to put 3 in for x, and let's see what you get. So if I put insert 3 in for the x spot, plus 4, now according to the word thing that I just said, I would square the number first, which would be 9, and 9 plus 4 would be 13. So that's what they mean by evaluating the function. I'll give you one more that's very similar to that. If they ask you to put in the square root of 5, square root of 5 squared plus 4. So when you square the square root of 5, you end up with 5, and 5 plus 4 equals 9. So that's what they're going to ask you to do for evaluating it. After that, they might ask you for the domain and the range of the function. Domain, I used to struggle with this when I was first learning this until someone finally just explained it to me is domain is the x values and range is the y values. Now, another thing that I've also referred to this as, that's your input, or the numbers that you're putting in, and the output is the numbers that you're getting out. Okay? So when you look at something for domain and range in this, what are the numbers you can put in, what are the numbers you're getting out? That's kind of what domain and range is, and I'll deal with that here in just a little bit. But for something like this, this problem that we had, the domain, we can put any number in. Doesn't matter. It's gonna work. So the domain for this last problem would have been, one way to write it is negative infinity to positive infinity, which stands for all real numbers. Okay, and then the range, when you put in the the lowest value you would put in would be 0, because if you put in negatives, you're going to get higher values out, and the lowest one that you would have when you put in 0 would have been 4. And the reason why I'm bracketing it is because it would equal 4 and not be not equal to it, I guess. So that would be the domain and range of that problem. I'll give you another one. If they give you another term, and sometimes what they do, we use f of x quite a bit, but there's times when we use other letters, and that just means a different function. It doesn't mean anything else other than that. I equate it a lot of times to pop machines, candy machines, water machines. They're all three doing the same type of scenario, but they're all three different machines, so therefore they might use like an F, a G, and an H, or something to that effect. So anyway, in this particular concept, they want you to put in the number 2, or negative 2, excuse me, and see what we get. So again, the first thing that would happen would be we would square the negative 2, which would be 4. A positive with a negative makes that a negative 2. And then 3 times 4 would be 12. Minus 2 minus 5. 12 minus 2 is 10. 10 minus 5 is 5. So that, again, would be evaluating it. And I can put in any number that I wanted. But as far as evaluating a function, that's all it is insert the number and see what you get. So in this case, part of the domain would be negative 2, because that's the number I put in. And part of the range would be 5, because that's the number I get out. Then the next type of function that we're going to have is we're going to have what we call a piecewise defined function. Piecewise defined function just means that we're going to have multiple pieces. So I'm going to give you a bunch of different scenarios, or a couple different lines, and then we have to insert the line in where it goes. Now, one of the problems that this book uses, and I kind of like it because it is something that we deal with every day, is your cell phone bill. Your cell phone bill is a piecewise defined function. This is how things get billed out. If the cell phone provider, whichever one you use, gives you 2 gigs of data, for instance. So on our smartphones we use data now. Used to be this problem was in minutes when we talked about cell phone minute usage, but now this is in terms of data. What this is saying is, if you use anywhere from 0 to 2 gigs of data, your bill will be $39. If you go over your allotted, then it will go into this line of billing. So when they say C of 1.5, is 1.5 between 0 and 1? Yes, it is. So therefore, when I evaluate it, my bill is going to be $39 or $39. If I ask you to see how much it would be if you use 3 gigs of data, now I've went over and above. Now I'm in line 2. So now it's going to be 39 plus 15, 3 minus 2. Or 3 minus 2 is 1. 39 plus 15 is 54. So, just so that you know, that's what a piecewise function is. Your cell phone is a perfect example of when things are billed at a little bit differently. It depends on what type of. A lot of bills are used piecewise. Usually, if you go over and above, then you get hit with a little bit higher rate or something like that. So, anyway. That's what a piecewise defined function looks at. What you need to do is look at what number you're inserting, like the 3 in this case, and see where it falls into this category or this category, which it falls into the bottom line, so I'd put it in the bottom line. If it fell in the top one, I'd put it in the top one. Okay? Or if it had 3 of them, I would put it in the one that it corresponds to. So just so that you are aware of it, that's what they mean by that. They're going to ask you to evaluate a piecewise, and they just want you to put it in the proper line and see what you get. Then after the piecewise functions, you're going to find net changes. Okay, and the net change, and we're going to use this again in a future section. But what net change is, it says f of b minus f of a, and what all that means is second answer minus the first answer. So they're going to give you a function, and then they're going to give you from this number to that number and see what happens. So to use one of the previous functions that we had, it was 3x squared plus x minus 5 from, now let's say 1 to 5. Okay, so what it's going to say is what's the net change from 1 to 5? How does it change? Does it go up? Does it go down? What is the change? So the first thing that you need to do is you need to insert each number. So if I put 1 in there, 3 times 1 squared plus 1 minus 5. So in this case, 1 squared is 1, 3 times 1 is 3, plus 1 minus 5 should give us a negative 1. Then when I put 5 in there, f of 5, 3 times 5 squared plus 5 minus 5. Well, 5 squared is 25, 3 times 25 is 75, 75 plus 5 is 80, minus 5 is back to 75. So according to my chart, I'm going to take the second answer, 75, minus the first answer, which would be negative 1, and 2 negatives would make that a positive, would make 75 plus 1, and it changed 76 different things. It's kind of like on a number line where you go from left to right, but in this case it would be the first one to the second one, where we changed it 76 times in order to get from negative 1 to 75. So that's what a net change is. You take the second answer minus the first answer. Okay? Then from here, they're also going to ask you to evaluate, but they're going to ask you to evaluate using different letters, which is not a big concern. We just put a different letter in for the variable. So if I give you the function f of x equals 5 minus 2x, and I want you to find f of a. Well, when I find f of a, 5 minus 2a, and I'm done. There's nothing else I can do with that because the a and the 5 don't mix. So as far as that goes, that's it. Now they're going to ask you to find f of a plus h. So when I put a plus h in there, what I like to do is I like to put that in parentheses. Anytime I'm inserting a number or inserting something for another letter like that, I usually like to put it in parentheses. Now what this means is I'm going to distribute. So I end up with 5 minus 2a minus 2h. And if I can combine like terms, I would do that. If I can't, I'm done. So at that point, I am okay. Now the next part might look a little confusing, but what they're going to say is find f of a plus h minus f of a divided by h, given that h is not equal to 0. And the reason why they just put that on there is just so that you know, hey, we can't divide by 0. Now that problem looks really, really complicated, but what it's asking you to do is take the second answer minus the first answer and then divide it by h. So the second answer, 5 minus 2a minus 2h, minus the first answer, 5 minus 2a, all divided by h. Now combine like terms. That's what they're asking you to do here. So if I take 5 minus 5, I get 0. Negative 2a minus a negative 2a, well, that negative and a negative here make it a positive, so therefore they cancel out. And I'm left with negative 2h divided by h, which ends up being negative 2. Okay, so when you're looking at the difference ones like that, they're going to ask you to find f of a plus h, and then find that big one. The big one, again, is just the second one minus the first one, and then you're going to divide it by h after that. And the reason why they put the h is not equal to 0 there is just to show you that, hey, I can't be equal to 0. Okay, or I can't divide by 0. And the last thing that they're going to ask you to do in this section is find the domain. Now, we talked about domain again, and what domain is the x values. Now, there are certain times when you cannot have a certain number. For instance, if you try to divide by 0, it's not going to work because you cannot break something into 0 equal pieces. It's impossible. So when we have a fraction, we're going to have domain issues. The other time is when you're going to see square root. And square rooting, you cannot square root a negative number without being imaginary. So for any time you have a square root or a fraction involved, we're going to have domain issues. If there isn't one of those things involved, then we should be fine. But what they're going to do is they're going to give you a function, f of x equals 1 over x minus 3. And right now I know I have domain issues. All real numbers does not work in this case because there's one number in the world that would not work. And so what I do when I have a fraction is set bottom equal to 0. Okay? So in this case, x minus 3 equals 0. And now I'm going to solve for x. X equals 3. Now, what that means is it doesn't mean it can equal 3. It means it cannot equal 3. Because if I put 3 back in there, I'm dividing by 0, and that's a problem. So a couple different ways you can write that. One is you can write x cannot equal 3. That's one way. Another way would be if you use interval notation, you go from negative infinity to 3, and then 3 to infinity. And basically what I'm doing is I'm cutting 3 out of the loop. Now, again, I use parentheses for this because if I put brackets on that, that would be equal to, and then I'd be dividing by 0, and you can't do that. So anytime you have a fraction, set the bottom equal to 0, and then solve it. If you have square root involved, so if I have g of x equals the square root of 7 minus 3x. You're going to set inside equal to 0 this time. So 7 minus 3x equals 0. So now I'm going to solve for x. So if I add 3x to both sides and divide by 3, I end up with x equals 7/3. Now 7/3, you could rewrite that as 2 1/3 or 2.3 repeating, but I'm going to leave it as 7/3. I just like the fraction look better in this problem. Now for this particular problem, we can equal 0 because you can square root 0. You just can't square root negatives. So 7/3 on a number line would be between 2 and 3. It would be approximately right here. And we can equal that. Now what would happen is, can I put numbers higher than 7/3 or lower than 7/3? If I put a number higher than 7/3, which would be 3, 7 minus 3 times 3, well, that'd be 9. 7 minus 9 would be -2. I can't go big, I can go smaller. So then everything would work out that way, which would mean in integral notation, -infinity up to 7/3. And it would be a bracket because you can square root 0. And what you do is you find the numbers that would equal 0 underneath the square root, and then you test a zone. Very similar to what we did in the previous chapter, where we were testing zones as far as which ones worked. So be very careful with that, but when you have a square root involved, that's what you'd end up doing. Now, if you have a square root and a fraction at the same time, then you have to do both. Or if the square root is inside the fraction on the bottom, then that would not have been a bracket, that would have been a parentheses. So for instance, if I would have put that over 1 or 1 over it or something like that, then that would have been a parentheses rather than a bracket. So something like that would look like this. If you had f of x equals x squared over the square root of 6 minus x. Now again, the top doesn't do anything unless the top would have had the square root involved, which it does not. But the bottom does, so I've set the bottom equal to 0, but the bottom is a square root. So if I set it equal to 0 and if I add x to both sides, I get x equals 6. Now this time, I cannot equal 6. What happens is if you try to put 6 in there, you're going to divide by 0, and you can't do that. So for this one, it's going to be like an open circle. Now if I put a number higher than that, 6 minus 7 would not work. That'd be a square root of -1 on the bottom, so it would be everything less than 6. So it would be -infinity to 6, but this time it would be a parenthesis rather than a bracket because it comes from the denominator of a fraction. If it would have been in the top, then we would have had a bracket on it. So be very careful with that when you're finding the domains. But as far as that one goes, that's it. When you look at the homework sections and whatnot, it says evaluate the functions, which means plug the numbers in and see what you get. Evaluate a piecewise, find the net change, difference quotient, which is where you put the a and the h and the a plus h, and then the domains, and that's pretty much it. So that's it for section 1. Thanks. Bye.